All right, guys, let's see how this works. So, uh, I tried to do it on my whiteboard, but my computer freaked out at school. So let's tackle this. Let's tackle im improper integrals. Okay, so here integrals. So this is what I've gathered so far on improper integrals, guys. So on improper integrals, we get stuff. Let's just kind of tackle one right off the bat. So uh, actually, let's add a couple of things. So uh, you have they're basically for things that have horizontal. Uh, Not sure what's going on, so it may totally freak out here. Horizontal asymptotes, and we have some for vertical asymptotes. Okay, so we're talking about let's see here, asymptotes. So we're talking about stuff that looks like this, like the integral of 1 to infinity of 1 over x dx. Okay? So this right here poses kind of a small problem. Or we're talking about like the integral of 1 to infinity of 1 over x squared dx. That's the idea behind these integrals. Okay, so let's just kind of look at this piece here, because if we integrate it and we just kind of plug things in, it doesn't work well, uh, because we also have to decide if it diverges. I'll write this over here in a different color. If it diverges or converges. Okay. So if it diverges, it ends up, you get an answer of infinity. So it doesn't go to an exact answer. If it converges, it actually gives you a finite answer. So it gives you a solid answer. You can find the the answer itself. Uh, so when we look at this, so there's really no upper boundary here. Kind of thing. So what we do is we reset this up based as a limit based on the fundamental theorem of calculus. So if we rewrite this, uh, this is literally going to change. We're going to change this to, and I'll go back to the black pen here, and we're going to change this here to 1, and we're going to change this. You'll see it as n. We'll just change it to b right here. B, right? We're going to change it to those pieces. And we're going to say, though, that the limit of this thing as b approaches infinity. Okay? So we're going to take this piece and we're going to turn it into a limit. All right? And so then, excuse me, this is going to be, this is going to be 1 over x dx. So let's integrate this. So we're going to rewrite it again. We're going to do the limit as b approaches infinity of, according to the fundamental theorem of calculus, is going to be the limit of, let's just write it all out. It'll be the limit as my brain just went dead. The natural log of b, because the derivative, the integral of this, minus the integral of 1. Okay, upper minus lower. And so when we do this, we get the natural log, yeah, that's right, sorry. The natural log of infinity minus the natural log of, well, I should have said, yeah, of 1, which is going to be 0. Let me go backwards. 0, right? So then what's the natural log of infinity? Well, that is going to be infinity. So my answer to this is going to be infinity. So it diverges because it's an infinite answer. So it's diverging. This one diverges. Okay. So then when we tackle this one, let me slide this one. Let me see if I can get it to move here. I don't know. There it goes. Let's move that one over. This thing. I haven't used this one in a while, guys, and I'm on my home computer. So let's just kind of erase that out of the way. So this one here, same idea. Let's rewrite it as the integral from 1 to b as the limit as b approaches infinity. Okay, and that is going to be 1 over x squared. Should have wrote it in the black one, but that's all right. So let's just kind of keep rolling this one. So let's integrate this one. So if we integrate this, let's go, and I'm just going to change it here. This is going to be the limit as b approaches infinity of 1 over x, and there's a negative there, right? Because if I bring it up, I'm gonna tackle that, and then that's going to be integrated from b to 1. So let's just kind of keep going with this, and we're gonna say that the negative. I'm just gonna move this negative out front. So let's say the negative at limit as b approaches infinity, and then that is going to be the answer of negative 1 over b minus negative 1 over 1, and b is going to approach infinity, correct? So when we pull this thing all together, we get negative times 0 plus 1. Where did my negative, I pulled the negative out. So sorry, guys. So I pulled the negative out. I forgot that I did that. I'm erasing those negatives because it's right here. Okay. So 0 plus 1, and that gives us an answer. No. Yeah, that's right. 0. It's not plus 1 anymore. Hold on. My brain's not working. I'm trying to rush this for you guys because the computer at school didn't work. And we get negative times 0 minus 1, which is 1. And since it's a finite number, this one converges. This integral converges. Okay? So let's do another one for you guys. Let's slide up here. And we'll do another one here. Let's call this one, let's rewrite it. This thing writes so much better. Let's just do, let me turn on my light here, guys. I can't see. 0 to infinity, right, of dx over x squared plus 9. So we're still dealing with this fact that infinity is in the way. So we're going to rewrite this thing. Why don't you guys try it right now and see what you guys come up with. Okay. And we're going to rewrite it as the limit as b approaches infinity from 0 to b. Now I'm going to write this one. Here we go. No, I'm going to do it in a different color. No, I'm going to do it in this one. 0 to b, and that is going to be of 1 over 9 over x squared over 9 plus 1. Okay? So you guys are probably like, what the heck just happened? So we have to rearrange this thing here so we can get it to where we can get the tangent of -1. Okay. So what we do is we take this piece here and we divide everything by 9 to create what we've got here. All right. And so if I divide this by 9, I get 1. If I divide this by 9, I get x squared over 9. I get 1/9 up here. So this allows us to deal with this being u squared. And this turns into 3 squared. So this becomes a 1/3 if you look at it. So this will become 1/3 out front here. And that is going to be of the limit still, the limit as b approaches infinity. Now this is where it changes because we just changed the problem and we turned it into our ability to tackle it from a tangent standpoint, because this here, when I have u squared plus 1, this becomes the tangent of -1 of uh, x over 3. Okay, so we did all of this to create this piece right here. And that is going to be evaluated from b to 0. So let's clean this thing up. Now I'm into blue here. So I've got 1/3 times this limit as, keep writing the limit idea because you got to keep rewriting it. The limit as b approaches 0 of 0, no, not shouldn't be 0 to b anymore, of tangent of b over 3, tangent -1 of b over 3 minus, why did this is infinity. I keep writing 0. I'm getting my brains confused. That should be infinity. Minus the tangent of 0. So we keep our 1/3 outside. And then we plug in this. Infinity's here. So this will be the tangent of infinity. So if I'm taking this and I'm plugging it into here, I get tangent -1 of infinity over 3. So tangent -1 of infinity. And now we got to know our trig here. So if we look at a graph of tangent at pi over 2 and negative pi over 2, this thing goes like this, right? So if I'm right here, what is pi over 2 approaching? Uh, when it's approaching infinity, I'm getting close to pi over 2. So that means I've got 1/3 times pi over 2, and this is just going to be 0 because tangent of 0 is 0 right here. And then that is going to be pi over 6. And that's a solid number, so it's going to be converging. Okay? All right. Let me do one more example for you guys so you have plenty of examples to start with, and we'll tackle the rest in class tomorrow. I got a couple more for you. Let's do this one in a different color. Let's talk about, this is going to be a little different now. So let's look at the integral from 0 to 1 of the square root, I write that? I did. Of dx over the square root of x. Okay? So this poses a little bit different of a problem here, because when we look at this here, when we look at this, I can't put 0 in here. 0 doesn't work right here. Okay? Because if 0 works, it gives us an undefined piece. So we have to look at this a little differently. So what we have to realize is that this thing, and this is where all the limit stuff starts to come into play from what I've learned in the last couple of weeks reading on these things. We got to approach it from the right. And so we got to kind of rewrite this thing a little bit. Okay. So it's going to be approaching from the right. So what we really are doing here is we're rewriting this thing as the limit approaches 0 from the right. That's a key piece. And then it's going to be of the integral. Oops, let me write this a little differently here, guys. Sorry, let me go back. Of b approaching 0 from the right, and it's going to be of this will be b and 1 will stay there because we're allowed to plug in 1 here, but we're not allowed to plug in 0. And that'll be of 1 over root x dx. Okay, so the big one on this was getting this all set up correctly because you had to kind of look and see what we couldn't come up with. All right, so let's tackle this crazy little piece. So now we're here. I'm going to change colors on you because now I'm going to integrate this thing. So now we're going to go limit of b as b approaches x 0 from the right. And then I'm going to integrate this, and I'm going to get 2 root x. And I'm going to do that from b to 1. Okay? I'm going to do that from b to 1. So now I can take this 2 and I can move it out front. I'm just going to finish it over here, guys. I'm going to take this 2 and move it out front. So that one's already out front. And then we're going to get the limit as b approaches 0 plus, and that's going to be the square root of, that's going to be 1 minus the square root of b. So I plugged in, oh my goodness, I plugged in my 1 and I plugged in my b. And so when I plug in this as it approaches from the right, the square root becomes 0. So 1 minus 0. So then we get 2 times 1 here, and our answer is 2. So that converges. Okay? All right. A couple of cool tricks I'll show you later, but that is all that we got for improper